Most students struggle with mole conversions. No matter how many dimensional analysis examples they look at, it just doesn't click. For those students, I recommend using a mole map, but we're going to use a variation of the mole map you may have seen in your textbook or online. A traditional mole map puts grams on the left. I'm absolutely going to do that still. Our mass is over on the left of our map. A traditional mole map also goes ahead and puts particles on the right. Let's go ahead and do that. Particles go right here. And then we know that moles is the heart of chemistry. Moles is the center. But instead of writing this linearly, grams, moles, particles, I'm going to go ahead and drop moles down. My units of moles, which is in the center, is going to be down so that my map now at this point forms more of a V instead of a linear line. Now, by drawing it in this way, it's going to simplify the math for us, because what we're going to be able to do is make a hard and clear rule for going down diagonal lines or going up diagonal lines. Let me show you what I mean. We know we can go from moles to particles or particles to moles, and the conversion factor that we need is simply Avogadro's number. I'm going to go ahead and write that right here on our line. 6.02 times 10 to the 23 particles is 1 mole. We also know that we can go ahead and go from grams to moles or moles to grams. The way that we do that is using the molar mass. I'm going to go ahead and again write that on my diagonal line. Okay, molar mass. All right, now what's the hard and fast rule? Basically, if you draw your mole map in this V shape, if you go down a diagonal line, what do I mean? If you went from grams to moles or particles to moles, I'm going down diagonally, you can always say that if you go down a diagonal line, you're going to divide by your conversion factor. If you go up a diagonal line, moles to grams or moles to particles, well, then we're just going to do the opposite. If you go up a diagonal line, you're always going to multiply. Let's go ahead and do an example. What if I said, how many grams of copper would you have if you had 4.0 times 10 to the 23rd atoms of copper? Let's write down our given information. They told us that we have 4.0 times 10 to the 23rd particles of copper, atoms of copper. Atoms is a type of particle. I'm going to write that right up here. 4.0 times 10 to the 23rd atoms of Cu. Okay, so that's our starting information. What they want from us is grams of copper. So the question mark goes over here. We automatically know that we have a two-step conversion. We're going to have to go from grams to moles first. Well, we have a conversion factor for that. And then we're going to need to go from moles up to grams. So we're going to use our molar mass. We need the molar mass. The molar mass of what? The molar mass of copper. Let's go ahead and find what that molar mass is in this case. If you look on the periodic table for copper, it has a molar mass of 63.546 grams per mole. I'm going to write that right next to my molar mass. Okay, 63.546 grams per mole. Now we can go ahead and do this problem. Here's our start, there's our end. So write down your starting information. We have 4.0 times 10 to the 23rd. Now we want to go over to the question mark. First thing we need to do is go down, divide, down this diagonal line to moles. So we're going to divide by our conversion factor of 6.02 times 10 to the 23rd. That's going to bring us to moles. The next thing we need to do is go up this line to get to grams. Well, going up a line, we just multiply. We're going to multiply by the molar mass of 63.546. Now, if you do that and keep 1, 2 sig figs in your answer, you're going to get an answer of 42 grams. All right, super fast, super great trick if you just want an immediate answer. But what if you have a teacher who's like, no, you have to show every single one of your steps? Well, we can use this map to make sure to help guide us or double check our work. So what if I was going to do this with dimensional analysis? It's exactly the same thing. Start with your beginning number, 4.0 times 10 to the 23rd, and the units of that were atoms of copper. Now, using dimensional analysis, we know we don't want atoms. So we'd go ahead, use a conversion factor that puts atoms on the bottom, atoms of Cu. And what can we get to from atoms or particles? We can get to moles of copper. And we know 1 mole is our 6.02 times 10 to the 23rd atoms. At that point, atoms would cancel out. And then you'd need to go ahead and get rid of moles. So we'd put moles on the diagonal down here on the bottom, and then we'd go to grams of copper. 1 mole is the 63.546. Moles would go ahead, cancel out. And then if you took all of that on your calculator, you'd get the exact same answer. But notice, the math checks out. You took 4.0 times 10 to the 23rd divided by 6.02 times 10 to the 23. Yeah, that's what we did here. And then you multiplied by the 63.546. Yes, that was our next step. And either way, we got an answer of 42. So use a map to quickly get an answer or to help guide your work. I hope that helps. Take care.